Hi, welcome back to my friend Permu's Patio. It's a beautiful day in the neighborhood, and as always, a great time to do math. Thanks for coming. This is the third part of the sequence on simplifying square roots. Hopefully at this point you've watched the rules for divisibility so that you'll know how to decide whether 2, 3, 5, and 11 go into numbers. And you'll also be comfortable with short division. Short division is really fun. You can make up as many problems as you want just sitting around, and I encourage you to give it a try. Today we're talking about prime factoring, and we need to remember what prime numbers are. So let's see if we can write down the prime numbers. 2, 3, 5, 7, 11, 13, 17, 19. And I'm going to put those dots up there to make sure that it goes, that it goes on and on, because so far no one's ever found an end to the prime. Well, what's different about these numbers? All of them are only divisible by themselves in 1, which is what makes them a prime number. So 6 is missing because 2 times 3 is 6. 12 is missing because, honestly, there are several ways to get 12. And 18 is missing, again, more than 2 ways to get it. Well, at this point, I want to be able to do prime factoring. And many of you have used factor trees up until this point. You've done something, for example, 24, 6 times 4, 3 times 2, 2 times 2, and then you circled all the primes. I don't favor the tree method. The reason I don't is it's too easy to lose factors up in the tree, especially as numbers start to get larger. So the method I use is a little bit different. We're just going to start off with 2, 3, 5, 7, 11. That's really all that we're going to think about, especially for smaller prime factorizations where we don't need anything larger. Let's take a look at 42, for example. My first question is, I'd like to know how many times 2 goes into this, if it does. Well, remember from our divisibility rules that 42 ends in 2, and so 2 does go into it. So let's divide 2 into 42, and that's 21. And if you have trouble doing that in your head, remember our short division. 2 goes into 4 2 times with nothing left over, and 2 goes into 2 once with nothing left over. So 2 goes into 42 21 times. Now I'm going to ask myself the question again, how many times does 2 go into 21? Well, this is not an even number, so there are no 2's. So let's move up to 3. How many times does 3 go into 21? 7 times. And whenever I get an answer here, I should always be asking myself, is it one of these prime numbers? Because if I hit a prime number at the end, then I'm done. So the prime factorization for 42 is 2 times 3 times 7. And that's pretty quick. Let's try another one, like 81. Well, does 2 go into 81? It's not an even number, so there are no 2's. What about 3? Well, let's remember our rule for divisibility. 8 plus 1 is 9. 3 goes into 9, so 3 goes into this. And that just makes sense because pretty much every one of you thought 9 times 9. Well, 3 times 3 is 9. So let's use our short division. 3 goes into 8 2 times with 2 left over. 3 goes into 21 7 times. Okay, now I've moved back into my normal times table realm, and it's easier to figure this out. Okay, are there more 3's? Well, 3 does go into 27 9 times. 9 is not prime, so I need to keep going. Does 3 go into 9? Yes, 3 times. 3 is prime, so I'm done. So the prime factorization for 81 is 3 times 3 times 3 times 3. And some of your teachers would like you to write that 3 to the 4th. I'm going to ask you to leave it this way as we go to simplifying squares. At this time, why don't you pick a number, say under 50, and see if you can prime factor it using this method. Okay, hope you had luck. Maybe did a couple of examples. We'll try prime factoring 48. 48 is even, so I'll start with 2's. 2 times 24, and again, if I need to do short division, 2 goes into 4 twice, 2 goes into 8 4 times, and I'm done. Now I'm on solid ground again. 2 times 12 is 24. This is not prime, but it is even, so 2 again. 2 times 6, not prime. 2's again. My final number here is 3, which is a prime number. So I'm done. The prime factoring for 48 is 2 times 2 times 2 times 2 times 3. Let's try one more fairly large one and see how we do. 225. Let's prime factor that guy. Well, there are no 2's because it's not even. What about 3's? Some of you wanted to go right to 5, right? But 3, interestingly enough, does go into this number. So 2 plus 2 is 4, plus 5 is 9. 3 goes into this. 3 doesn't go into 2, but it goes into 22 7 times with 1 left. 3 goes into 15 5 times. How about now? Don't just jump straight to 5. Does 3 go into this number? 7 plus 5 is 12. 3 goes into 12. So hopefully you recognize if I have 3 coins in my pocket and there's 75 cents, I've got 25 cents. I've got quarters. But if I want to do short division again, 3 into 7 twice with 1 left over, 3 into 15 5 times, and now I think you can see the end game. There are no longer any 3's because 2 plus 5 is 7. So I'm going to move up to the next one, 5. 5 times 5 is 25. And I hope you can see at this point how much utility just 2, 3, and 5 have when you have to do prime factoring. Now, as I look back at this, one of the really amazing things, and I hope you noticed this yourself, not only do I get the prime factor, but I get a lot of other factors of this number that may be useful to me, especially in Algebra 1, when I'm trying to figure out how to factor expressions. Like this is great. 48 has 24, 12, and 6. 81, which is a number that we just think of as 9 times 9 usually, 27 as well as 9. And then 225 has 75, 25, 3, and 5. It doesn't give you all the factors. Sometimes you might have to go back and multiply. So for example, do I think 9 goes into 225? Sure it does. 3 times 3 goes into 225. How about 15? 3 times 15 goes into 225 as well. In fact, 225 is 15 squared. And if you think about this a little, you may be able to see where we're going in the next section on simplifying square roots. Thanks again for coming, and we'll see you in our final section on simplifying square roots.